Right, good afternoon, everyone. Thank you for staying for this session. It's 4:25. It's a lovely sunny day. The pubs are open, but you want to talk about data modeling. It's a reflection on you as well as me, right? So that's good news. So I want to talk to you about 3 data modeling techniques in 2023. And the question is why? What's the difference between 2023 and 2022? Well, the biggest difference is data cloud. So data cloud gives us a scale possibility that did not exist on the platform in 2022. Can I get an understanding just in here, how many architects have we got in here? Okay, how many devs? How many admins? Any salespeople? Oh, brilliant, there we go, perfect. Okay, right. So before we start talking about data cloud and what data cloud is, let's think about what we did to data model things in Salesforce before 2023. So things start with our trusty sObject. So this is our transactional workhorse that's existed in the platform for 20 years. And pretty much when you build things on Salesforce, you're going to be using an sObject. And it has lots of good properties. You can apply sharing to it. You can use it declaratively. You can use it in code. So it's a pretty strong object. And the sObject is, of course, going nowhere. It's the way the core platform was built. If you don't want to use an sObject, and this will be good for you between thousands or maybe even millions of rows, maybe you want to use a big object. And a big object, again, sits on the platform within the Salesforce trust boundary, but this is about data at the millions or billions of rows worth of scale. And this I see really as almost like a warm archive on the platform. So there are some tools on the platform to access big objects, so you can display them like they're a related list. But generally you are working with code using things like asynchronous SOQL to be able to query a big object. There are tools on the App Exchange that make that a bit more declarative, but that's kind of where big object sits. Then at completely the other end of the scale, we have the platform cache. Now this is a highly denormalized, non-persistent data store, but you might use this if you have very fast changing data, or potentially you want to create an experience for a user which is really fast. And if it doesn't have to query multiple sObjects and multiple relationships, you may want to store things in platform cache. But that is very much a pro code option, right? The data is highly available, but it's stored in JSON format. You're going to have to write code to get data in and out of the platform cache. And then the final area, which again, I know we're all here focused on Salesforce, but the reality is, in any enterprise architecture, there are going to be other systems in the estate. So with Salesforce, developers, admins, and architects, we're there saying, how do I give my users, who tend to be using Salesforce as their platform of engagement, all of the data they need at the right time? And before 2023, we might say, right, I'm going to pull some things from the enterprise estate, I'm going to push it into Salesforce, I'm going to work with it, I'm going to let the users see it, and then I might choose to archive it, maybe choose to move it to a big object. And that's kind of the data model options that we have in Salesforce before 2023. So the sObject is great for lots of reasons, and again, I'm going to focus mainly on the sObject here because it's the thing we use most commonly. There are some challenges with an sObject. So fundamentally, the sObject sits on the multi-tenant platform, and as a result, we are all subject to scale and sharing resources. So there's only a certain amount of compute, there's only a certain amount of DML, and that's why we have governor limits. So with regards to those governor limits, it generally involves how many rows of data you can pull back and query in an sObject at any one time. So I think if any of you have worked with Salesforce, you'd have seen things like only pulling back 50,000 records in a single query. You may well have seen the SOQL 101 error, where you're making too many queries per transactions to the database. And then if you do want to work with that data at scale, maybe you have your thousands or millions of rows and you want to run a batch job on it, you're then subject to the things like the number of concurrent batch jobs that exist. So from a Salesforce perspective, storing thousands or millions of rows within sObjects, within big objects, is all well and good, but when you want to calculate on that data and work with that data, it starts to become a bit more tricky because we have to factor in those governor limits. So what do we have in 2023 onwards? What is now our option with Data Cloud? So I've listed the ones that we talked about before, the big object, the sObject, and the platform cache. And then in this blue box, this is where Data Cloud is going to appear. But most importantly, Data Cloud is within the same trust boundary as Salesforce. So if you have Salesforce secured as a platform, the Data Cloud is going to exist within that same trust boundary. And the way that you model data in Data Cloud is a little bit different. So the first thing that you start with is a data source object. And what a data source object is the raw data that you ingest from a system. What do I mean by a system? I mean many things. It could be an sObject. You could pull contact data into the DSO. You might be pulling it from an enterprise system. But it's ultimately the raw data. When you've got your raw data into the DSO, you're then going to move it into a data lake object. And the reason it's being moved into a data lake object is you're probably going to want to work with it in some way. So if you need to identify resolution, if you need to do matching, if you need to calculate insights, you're going to be doing that on a data lake object. And as I'll explain shortly, the data lake object is designed to work at petabyte scale, so billions, trillions of rows worth of data. And when you've achieved that insight, you'll then move that data into a data model object. And when you move the data from the DLO to the DMO, you're also going to define your business taxonomy. So let's say you have 3 different data sources. They all describe the contact first name in a slightly different way. In your data lake object, you will reconcile that contact first name, and you will present it as a standard field called first name in your data model object. What do you do with it in a data model object? Well, you've got 2 options. So first of all, the data, every row in a data model object is published as an event. So if you want to subscribe to that event, and you want to pull the data from the row in your data model object, you can do so and then either store it in Salesforce as another sObject record or potentially fire it to a different enterprise system. So that's an option. The other option with a data model object is you can virtualize that data. So when you use Data Cloud, there are standard Lightning Web Components which can point to a data model object which allow you to then virtualize that data. So, a question that you'll have even before Data Cloud, should I actually put this data in Salesforce? Well, here's an answer where you can work with it in Salesforce, but you don't actually need to move it into an sObject. So it's still within your trust boundary, it's still being referred to by your users, but it's not taking up the storage, the compute in an sObject that you might want to try and avoid. And of course, there's your enterprise estate. Your enterprise estate's still going to be there, and you can choose to ingest data into your DSO and then move it through your DLO and DMO process from the enterprise estate. So instead of pushing that directly to an sObject or only referring to it in the enterprise estate, you can connect your enterprise estate into your data source object before deciding what to do with that data and how to organize your DMO. Now there's 2 big benefits for this. Number 1 is scale. So the scale for Data Cloud is huge. It's petabytes worth of data. And the second thing is the number of data sources you can choose to use. So if we think about our trusted objects on the right, so our sObject, as a Salesforce architect, you are naturally constrained about how much data you want to push into that sObject. And you usually do that to kind of cut your cloth and decide what data should I move from the enterprise, how should I work with it. If you don't need to push that data into an sObject, but you can still work with it, you can still reconcile it, you can still refer it to your CRM data, and then present it virtually, that's a good option to work with large-scale data that doesn't necessarily need to be a transactional data in an sObject, and that's the other big advantage of Data Cloud. And what does it actually mean from a scaling perspective? So architecturally, the most important thing to know about Data Cloud is it's entirely different to an sObject. So an sObject is row-based storage. And that row-based storage is in third normal form, and it's really useful for relational databases. So you're describing that business taxonomy, you're using it in a relational database type format. That's what an sObject does. But the Data Cloud is built on what's called a Parquet, which is a columnar data store. And a columnar data store is designed for query scaling. What that means for us is we can have up to 100,000 requests per second. You're not going to get anywhere near that in anything on the core platform. And you can deal with that petabytes worth of data. The other thing about Data Cloud is it's, I guess, a little bit more of an open format compared to the core platform, which has some proprietary things like Apex. So you can have multimodal access on the Data Cloud. So you can still write SQL if that's what you're used to, but you can also write SQL. You can use files to ingest data rather than rows. And there's various different ways of connecting to the data and using it, either from REST or from Lightning Web Components. The other two important things at the bottom of this list, zero copy file-based access. So I think this is pretty cool, because if you're thinking, okay, well, we've already got a data warehouse, I don't particularly want to take all of that data out of the data warehouse and stick it in the data lake, you don't necessarily have to. So there is a zero copy pattern, which means we can point data cloud and that data source object at, for example, Snowflake. We can work with the data in a data lake object, but we don't ever need to physically move it or replicate it outside of Snowflake. So that's pretty powerful if you already have large data stores that you want to refer to. And the final thing is it's metadata driven. And I'd sort of take this at two angles. Angle one is it's metadata driven, which means you can deploy to other orgs and you can use it in the same way that you're used to working with metadata in Salesforce. The second thing is it's mostly declarative. So I won't call it completely no-code. It's more on the low-code side than the no-code. But what that means is that when you are an administrator or a developer, you will recognize the interface. It is built on the Lightning design system. It looks like Lightning. The way that you access and you set up data source objects, you'll be very familiar with. So from a learning perspective, once you understand the concept of what you're trying to do, it's actually pretty easy to get your head around. So what I want to do now is kind of look at 3 data model patterns, look at how I would have done them in 2022, and then look at how I might do them in 2023, and see if we've gained anything. So the first one is around reference data. So in this example, let's imagine we have a business that has an ERP system. In the ERP system, there are orders. When orders are created in the ERP system, we want to send a task to a service rep so that they contact the customer. So the service rep needs the task in Salesforce, and it needs to be able to see the order so it can understand what the customer has ordered. So before Data Cloud, I'd probably do something like this. So I would get my ERP to push my data into my sObjects, and I would potentially do that identity resolution either using sObject tools or potentially in the integration layer. So I would want to try and insert a replicated copy of that order record into my sObject, and then when there is a record created in that order object, I would perhaps use an after save trigger or maybe a flow in order to create my task. Now that's going to work perfectly fine, but there are a few challenges with this. First of all, that order object is going to grow pretty large. And if we're not archiving that data, it's going to become pretty cumbersome for the user to operate with. Also, if you change something in the ERP, you're then going to have to change your sObject logic, the after save or the flow logic. You're going to have to do that, and you're going to have to change that in metadata if something changes in the ERP. But again, works perfectly fine. I'm sure it's something, a similar pattern that you've all used before. So how would we do it with Data Cloud? So this is how we're going to operate with Data Cloud. The first thing we're going to do is use an sObject as one of our data source objects. We need the account records to be pulled across into a data source object because that stores our primary key for what the account is. The ERP is no longer going to connect to our sObjects. Instead, it's going to be another data source object that we connect to. In the DLO, what we are going to do is we are going to combine the data sets of the account and the order to be able to reconcile them. And then we're going to produce 2 DMOs. DMO 1 is going to be a list of all of the tasks that we need to create, and DMO 2 is going to be a list of all of the orders. And what I'll do with these 2 DMOs is slightly different. So the first DMO, the task DMO, I'm going to use that to insert a record in Salesforce. If you remember, every row is an event. So I'm going to subscribe to that event, and maybe through a flow or a trigger, I am going to write a task into Salesforce based on what that data model object describes. And it's going to be a pretty dumb thing, right? It's just going to go, show me what the row of data is, insert it into the task object. I don't need to put any particular logic into that trigger. From an order perspective, I don't want this or need this in Salesforce. So I'm going to virtualize that DMO, and I'm going to present it in a Lightning Web Component so that my service rep can see the order and has the task in Salesforce. So what we've done with this is we've avoided pushing all of that order data into Salesforce. And the second thing we've done is we've created the logic to work out what does the task look like, how do we reconcile the account logic outside of Salesforce. So we're not performing SQL queries, we're not doing loads of DML, it's instead happening in Data Cloud, which is built to deal with the scale that we might deal with over time. The next pattern is around batch account ratings. So this one's a little bit more complex. And the way that I want the batch account ratings to work is, first of all, I want to calculate all of my hot accounts in Salesforce. I then want to find all of the opportunities that are at stage 3 or later for those hot accounts, and I want to stack rank them. So the sales team could look in the org and say, right, here's all of my hot accounts with stage 3 or beyond opportunities, and I can see a stack ranking for me. So how would I do that before 2023, before Data Cloud? I'd be doing probably quite a bit of coding here. So I am going to be taking my sObject, and I'm going to be writing some batch classes. I am going to query the opportunities. I'm going to update the account rating to hot, and then I'm going to store all of those hot accounts in a map. The next thing I'm going to do is I'm going to calculate the opportunity totals of those that are over stage 3. I'm going to order the hot accounts map according to those opportunity totals, and then I'm going to update the account ranking based on the stat ranking that I've created. And again, that's going to work perfectly fine, but as a Salesforce architect or developer, you're going to have to be thinking about your limits. You're going to be thinking, right, this is going to count towards the 100 active scheduled jobs limit. I think the most restrictive limit when it comes to batch, because batch is a pretty resource-intensive process, is the number of running jobs you can have. So if your sales team is saying, hey, look, I want hourly updates to this field, you're going to start to struggle when you can only have 5 running jobs at any one time. So again, I see very often lots of batch processes put into Salesforce to avoid per transaction limits, but then you find that you can't run them all at once, so you have to kind of stagger them a bit more. So that's a bit of a challenge. And of course, it's maintained in code. You're going to have to make a deployment if you want to update that logic. So what about in Data Cloud? Well, we're going to use the sObject again as a data source object, and there's 2 things we need to pull out. We need to pull out the account object, and we need to pull out the opportunity object and store those as DSOs. We're going to harmonize and unify the data through the data lake object, so we've resolved the identity, and then we're going to use those DLOs to calculate the insights. And from those insights, I'm going to produce an account rating table and an account ranking table. Now, both of these things we could combine into one, and I'm then going to subscribe to that DMO, which will be an event, in order to push that update back into Salesforce. But the benefits of this are we're not going to write any code to do it. This will be maintained via clicks. And if I want to change my logic, maybe it's stage 2 opportunities, maybe the opportunity amount's gone up, I'm not having to make an update and a deployment to that in order for me to be able to make that change in Data Cloud. Okay, pattern 3. So this one is a very traditional multi-org process orchestration type scenario. So you have multiple orgs doing different things, and you need to be able to reconcile what's happened in a couple of orgs and move it into a different one. So in this example, let's say we have 2 sales orgs, maybe they're per region, and the sales teams are working in those sales orgs closing opportunities. We only have 1 service org, and in the service org, we store the entitlement. And what we need to do is anytime an opportunity closes, we need to look at the entitlement, work out what's changed, and then update that entitlement record. So how am I doing that before Data Cloud? Before Data Cloud, I mean, there's a couple of ways I could do it. I could either choose to take all of that opportunity data, all of that account data, and stick it in the service org. So I might use Salesforce Connect, or I could do something like asynchronous Apex or a flow to then calculate the entitlement. So that's one option where I'm having to replicate data. The second option, again, is I could use the event bus. I could publish the opportunity that's closed as an event. I could maybe use logic in the middleware to go and query the entitlement, work out what's going on, look at the changes on the event queue, and then calculate the new entitlement. So again, that's an option. Both of those are valid architectures, but it's what's your poison? Do you want your poison to be maintaining this logic in the integration layer? So if something changes or you need to scale, you need to think about that. Or do you want to push all of that data into one single org and then potentially have to deal with conflicts, with race conditions, etc., because you're pushing all that data into your service org? So what do we do in a Data Cloud world? So in a Data Cloud world, we are going to point the 2 sales orgs at Data Cloud. And we're going to use the accounts and the opportunities created in those orgs in a data source object. So we have them in our data source object, and we then need to harmonize and match them. So we are going to create a DLO, which is going to reconcile that data, and then it's going to push the data into a DMO. So we now understand all of the opportunities that have changed, and through the entire, sorry, I missed one thing. We're going to also pull the entitlements in as a data source object, and then with that added to your DLO, you can calculate the opportunities that have closed, the entitlements that existed, and the change you need to make to that entitlement. So what you're going to do with the DMO is store the newly updated entitlement record. You're going to subscribe to the event that that row creates, and you're then going to upsert the record in the DMO back into the service org as a entitlement record. And I guess the key thing with this is really much more scalable than the previous pattern. So if we choose to add a lot more sales orgs, we can just add those in as a new data source object. It's doing the same thing, right? It's pulling an account, it's pulling an opportunity, it's reconciling that data. It's not going to be great shakes to add that pattern in and add more orgs. You're not having to maintain things in an integration layer, and the data that you're storing in Salesforce is going to be clean, it's already been calculated, you're not having to process that within your sObject. So that's good from a limit point of view. So I think the thing to sort of take away from this is scale is a big thing. That there are certain things within Salesforce that they might be very simple, you might not be getting anywhere near limits, keep it on the core platform, keep it working in Apex in an sObject. But there are certain things which from a scale perspective, you just won't be able to do on the Salesforce core platform. And I think the big challenge for me as an architect, I talked at the start about what you do when you have billions of rows of data. Usually, we push it out of Salesforce, we send it to a data warehouse, and there's some kind of insight that happens on the data warehouse. But 9 times out of 10, despite our best intentions, that data never gets back into Salesforce. And your users are going, right, so I want to see in-context data about my accounts that's been calculated in the data warehouse, but I've got to leave Salesforce to do it. So one of the big advantages of this type of architecture is we can do that large-scale calculation, but we can still present it back to the user in the way that they're used to seeing. Right, so I'm pretty much on time, so I just want to quickly go through these. Architectural considerations for using Data Cloud. So the first one is around identifying your data sources. So I'm not suggesting that with Data Cloud, you just go to an sObject, pull it out, stick it in Data Cloud, and that's the way that you do large-scale processing. It's an option, but I think you're kind of underplaying what the platform can do. You should be broadening the data sources that you pull into Data Cloud, because the chances are there are systems that are doing things that will be very interesting to your users in Salesforce. You don't need to store the data and replicate it in the same way. You just want to bring it in, you want to calculate something based on that data, maybe reconcile it with your Salesforce data, and then present it as a DMO. So you can widen the number of data sources that you ingest, and therefore the richness of the data that your users can see. Remember the bring your own data warehouse pattern. So you might have a BI team getting really quite hot under the collar about these suggestions from a Salesforce architect, but in reality, we can do bring your own patterns, and their day-to-day job doesn't need to change. It's just we can take advantage of their insights and their work more directly on the Salesforce platform without having to build a custom integration. It's also a good opportunity to remove debt where Salesforce is a proxy. Maybe you've got a legacy system, you retired it, you stuck it in Salesforce, but it's really not doing anything from a transactional perspective, so why is it in an sObject? Maybe storing it in Data Cloud, storing it in a DMO is a better answer than doing it in an sObject. And also I'd say really consider your enterprise modeling. There is a stage in Data Cloud when you move from a data lake object to a data model object where you define the taxonomy. So you say, I define contacts like this, I define accounts like this, and having an enterprise data model will ensure that whatever mappings you take from a source system is in line with what your enterprise data model is, and therefore is of the taxonomy that your business will recognize. Now, here's a big one. This is based on consumption-based pricing. So in Salesforce, we're used to per user per month, right? That's kind of how it operates. But this is actually under the hood, all built on AWS. And AWS are invoicing Salesforce for the amount of compute that you're using. So as an architect, you're going to have to think much more carefully about what this service is going to cost. You're not going to buy a license up front, but you are going to be charged based on what you use. So from that perspective, 2 considerations. Number 1, do you really need to run it every 5 minutes? That's going to be quite expensive. And number 2, what is the environmental impact of doing this? So I think from a kind of sustainability point of view, we all have a responsibility to think about how often we need to run these processes and the sort of compute power that that's going to need. And as I said before, don't put everything in Data Cloud. Some things are really simple, do it in core, that's absolutely fine. But when you are getting to scale, and when you're really having to jump around and go through hoops to meet limits or to not meet limits, it's probably time to think about doing something in Data Cloud. And then your other choice, do you virtualize or do you use events? The big question we're always asking ourselves, do we need the data in Salesforce? Well, you have two native patterns that you can use in Data Cloud if you want to go either way. And again, the results don't necessarily need to be the source in Salesforce, they can just be represented via a Lightning Web component. One thing to be aware of though, if you are going to use events, remember that that is going to count towards your platform event daily limits. So there is a number of events you can choose to subscribe to in a 24-hour period. It's Salesforce, you can buy more, but think about that in your designs. And again, the other thing I'd say, now that we have event-triggered flows, be nice to the people coming after you. Write your logic in a flow, don't write it in a trigger. And my argument for that would be, if you're no longer calculating lots of difficult things, you really don't need to write that in Apex. You can write it in flow, and that will be absolutely fine from a complexity point of view. And it's multimodal. So look at what source objects Salesforce supports, because there is a fair chance that the data source that you have is already supported with Salesforce, and you might not need to convert it in order to push it into the Data Cloud. The other thing I'd say is, we all love SQL, but SQL is a far more powerful, richer language. So if you can learn SQL, do, because I think it will really help you. But it may be that you need to use skills within your BI teams to be able to set up the right SQL queries and for you to be able to work from there. So it looks and feels a lot like core. It exists on core within the trust boundary, but there are certain large data patterns that as architects of sort of transactional Salesforce we might not be used to, and you might need the help of your BI teams to be able to realize that. Right, I think I am over. Are there any quick questions, perhaps a minute? Yeah, go for it.
What are the kind of main limitations or disadvantages to using Data Cloud compared to the standard SObjects? I'm thinking if you're virtualizing and showing the data, maybe you can report on it together with the other Salesforce data, stuff like that. What are the main bits when you wouldn't want it?
So that is a key point actually. So from a reporting standpoint, if it's virtualized in that data model object, you can't see it in Lightning reports. You can see it in Tableau, you can see it in CRM Analytics, but you can't see it there. So yeah, I agree, that's a disadvantage. But again, I suppose from an advantage perspective, when you are reporting on that data and it's particularly large, you're going to get much better query results if it's stored in a DMO as opposed to if it's stored somewhere else. Okay. Any other what, sorry?
Any other disadvantages other than this?
What, of Data Cloud?
Yeah, compared to using the standard SObject.
Well, I suppose one of them is from a price point of view. So depending on exactly how much you put in there and how useful it is, you are being charged based on how much processing you do, right? So it's not even just about storage. So if you're not careful with how you architect that, that could be from a kind of an IT procurement perspective. You're getting a bill every month and you're going, oh my goodness, this is quite big. So yeah, it could be problematic. Right, I better finish there. Sorry, I'm happy to take it afterwards, but I need to finish this up. Okay. All right, thank you everyone.
What we've seen is that there's market overload. People are buying really expensive technology, but they're really not making the most out of it.
We want to show people can strategize now to plan for the future and plan to kickstart those projects.